Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, sketch the graph of a function with the following properties. So let's analyze these properties. So the first property is that the derivative of f at x is greater than 0 when x is less than 2 and x is between 2 and 5. So these intervals represent the intervals over which the function f at x is increasing, because the derivative of f at x is greater than 0. So as per the second property, so the derivative of f at x is less than 0 when x is greater than 5. So this is the interval over which the function f at x is decreasing. Because the prime of f at x is less than 0. Next, we are given that prime of f at 2 is equal to 0 and prime of f at 5 is equal to 0. So that means there are two critical points in this function. So the first one is x equals 2 and the other one is x equals 5. So at these two x values, the slope of the tangent is equal to 0. So the tangent is horizontal. Now as per the next property, the second derivative of f at x is less than 0 when x is less than 2 and x is between 4 and 7. So that means over these two intervals, the function is concave down because the second derivative is less than 0. So next we are given that the second derivative is greater than 0 between 2 and 4 and x greater than 7. That means over these two intervals, the function is concave up. And lastly, we are given that f at 0 equals negative 4. So this is a point that lies on the function f at x, and the point is 0, negative 4. So these are the given properties for which we have to graph the function f at x. Now before we sketch the function, we should summarize these properties on a number line over the intervals that are given, so that will help us understand how we need to sketch the function over the given intervals. So let's start with the number line. Now the given intervals have the x values 2, 5, 4 and 7. So we will break down this number line using these x values. So we'll start with the smallest x value, which is 2, and then 4, and then 5, and then 7. Now as per the problem, so we identified that the function is increasing when x is less than 2. So on the left side of 2 on that interval, the function is increasing. So we are just summarizing the properties so it becomes easy to sketch the function. Also, when x is less than 2, the function is concave down. So that's the next property. Now at x equals 2, there is a critical point. Now between 2 and 4, the function is increasing as per the first property, and the function is concave down, or concave up as per the second last property. Now we can analyze the interval from 4 to 5. So between 4 and 5, the function is increasing as per the first property. And between 4 and 5, the function is concave down. Now at x equals 5, there is a critical point. Now between 5 and 7, the function is decreasing. And between 5 and 7, function is concave down. Now to the right side of 7, function is decreasing. And to the right side of x equals 7, function is concave up. So these are the properties we have to show in the sketch of the function. Now we can sketch the function based on these properties that we identified on the number line. So let's start by drawing the grid. So the first thing we can show on the grid is the given point 0, -4. So let's assume it's somewhere here. So this point lies on the function f at x. Now we can show the x numbers that we have on the number line. Now we can analyze the intervals. So on the left side of x equals 2, the function is increasing and concave down. So that means we can show the graph going up from left to right. So the graph has to pass through this y-intercept, and it is concave down. Now at x equals 2, there is a critical point. The tangent is horizontal because the derivative is equal to 0. Now between 2 and 4, the function is increasing but concave up. So that means from left to right, the graph has to go upward but should concave up. So we can show it like, no, not like this. Okay. So like this. So this curve is concave up, and at x equals 2, it becomes horizontal because the tangent there should have a slope equal to 0. We can modify it a little bit more. We can make it look more horizontal at x equals 2 by making it go like this. Yeah. Now between 4 and 5, the function is increasing but concave down. So we can extend it like this. Now at x equals 5, there is a critical point. The slope of the tangent is equal to 0 because the derivative is equal to 0 at x equals 5. Now between 5 and 7, the function is decreasing and concave down. So we can show it like this. Now to the right side of x equals 7, the function is decreasing but concave up. So that means it will continue going down from left to right, but the concavity should be up. So it can go like this. So this can be the sketch of function f at x based on the given properties. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.